Actually, on my so on my background, I'm in the office actually, and it is on my background a painting, a photo from the typical beaches here in the North Germany, which are also quite nice in the summertime. At this moment, we have snow. And now I'm going to present a little bit something about ourselves. So first of all, here in this first slide, it's a little bit my history. So I was in Italy professor, then I was also professor in Denmark, and I participate in Denmark with some leading role in the Center of Reliable Power Electronics. So, but I am cooperating, and I'm still cooperating with Aalborg University in Denmark from almost 20 years. You may know that Denmark was very advanced and is still very advanced in the field of renewable energies. So I was very active in the field of renewable energy and later on the reliability. This is a book you see that I've been writing, also used for part of my courses, and other things is that I got the so-called European ERC Consolidator Grant, which they are excellence grant in Europe, which are given to one person to carry on a certain research. What I did actually in the last 5-6 years now, this project is completed, and then. Also, I'm quite proud of the fact that I always been both in Italy as in Denmark, very active in research laboratories with the companies, like similar you have in Nantes with with Renault. In Italy, in Bari, was with the company Avio. In Denmark, we had this Center of Reliable Power Electronics with the major Danish company like let's say Vestas or Danfoss and so on. And now we will go to start in the next year another research center in cooperation with Fraunhofer with the goal to stronger interact with the companies. So that is actually I like to make research, but also a lot of interaction with the companies. And these are my main field: the smart grid, wide bandgap devices that are new power electronic devices, which they have a special characteristic. They can reduce very much the losses of power electronic, and then the field of reliability, because we see, especially in the automotive sector, that there is very high requirements in terms of reliability. That is my team. There are 2 technicians in the team, and there are 4 secretaries who are helping us and will help also you when you come to Kiel, and if you join my chair. And then there are 6 persons which are more senior person. 3 of them, they are leading the 3 main group of my chair. So Dr. Santepugliese is coming from Bari, my previous university, is a postdoc, and is responsible of the control and reliability group. And Felix Hoffmann almost got a PhD, is more in the hardware, so power converters and batteries, which is also strong focus as we show later on. And Marius Langwasser is more responsible for the part of electric grid, is also almost finishing his PhD. And then there are other 3 senior guys in this group. They are also assisting, and then there is, as you see, a lot of PhD students. Some of them you don't see yet the faces, because for this Corona situation, they don't yet achieve to come to Kiel. But I mean, some of them, meanwhile, they were able to reach us. So first of all, I think as a student, maybe you are interested to see the laboratories which we have, because it's a very important part of your work or learning work in a master, not only the theory, but see what you can do in the laboratories. And that is the reason why I put this forward. So this is a laboratory which allow to test power converters, which they are connected to the electric grid. For example, you have a charging station and you have a power converter which connect this charging station to the grid. We can test them We have 7 power converters which are controlled with an interface card through DSpace, and so we can test all control algorithm. And then we have a computer that you see on the, I will use now a pointer to show it a bit better. Yeah, so here it's a kind of supercomputer where we simulate the grid, and then an amplifier, which is actually generating a voltage commanded by this supercomputer, and then this is power amplifier is connected to all these inverters. We have used this system, as I will show later on, in also to emulate, for example, part of electric vehicles. So-called hardware in the loop. It's a very, efficient way to design power converter and controls and to test them. And we do a lot in that direction. We have more system, as I will show later on. Then this is another strong aspect, I say, reliability, and I say as automotive field is very important, the aspect of reliability. What does it mean? It means that you look at especially power semiconductor and capacitor. You try to measure the temperature, so to see the temperature of these devices. You can see in the center of this slide that you basically have a profile of the so-called junction temperature of semiconductor, which is varying a lot. And so you imagine semiconductor something very small, the temperature is fluctuating in a crazy way, and then the semiconductor is within a packaging connected to the rest of the system. So this is a mechanical structure which is subjected to incredible variation of the temperature. And so basically you can have some crack, some failure because of this temperature variation. It's very similar to what's happening in a building that maybe is under the variable temperature, and then of course the mechanical structure gets subjected to this stress. And in the power module, it happens exactly the same. And already in Aalborg, I was developing a lot this field, and then also I'm doing that in Kiel now. So we measure with the special devices the temperature of the semiconductor, of capacitor, and we can see in operation. So we can take, for example, take an inverter from electric vehicles connected to a machine. I will show later on a very nice setup we are building that is exactly that the case. And you can see the temperature in different points and see which kind of expectation in terms of lifetime this system has. Yeah, and in the power electronic laboratory, we built also a lot of power converters. This figure was done by a former PhD student, which was, of course, very proud of the result he achieved. You see the different power converters in terms of efficiency and power, and our prototype, which you see here, they are based on the silicon carbide devices, and we do a lot of design also of the drivers. So we do a lot of electronics. We see also, we test from the temperature point of view, you see if everything is working as expected. We come to new topologies, they can save the cost and increase the efficiency. So we do quite a lot also in the power converter design here. Yeah, and then as I say, we do a lot using this power in the loop, and I already told you that we are expanding our capability, and the capability we expand in the sense that we have a building facility to test the hybrid grid, AC/DC grid, which they are basically generated by power converter, which connect these different grids, and then part of the grid you have in the reality, and some part you want to emulate, and then we use this this Opal RT. This is another part of our building. And nearby there is, and will be connected to this, a brand new laboratory, a medium voltage laboratory, which is used to test large power converter with high power, medium voltage. And this is a very hot topic when it's coming, for example, to charging station. So if you want to test a charging station, we can do typically, let's say, this Tesla supercharger and then you have a megawatt power range, and then you need the laboratory to test that, and that we have here. This is it took 5 years to build this laboratory. It was quite complex to get it. Now it's in operation, and you see not only in operation, we have some prototype from companies. So this in the cell one is a large modular converter, which we connected directly to 10 kilovolt network built by some students in cooperation with ABB in a project. In the middle, actually something that has not to do with medium voltage, but you have high current. So with Danfoss Silicon Power, which in the region is actually producing power module for semiconductor, and it is actually in the automotive in the field. So I mean, in the automotive field. And then in the third cell, we have so multi-level converter, which they circulate at something like 500 amperes. So it's quite large system. They are all 3 cells in operation at the moment. We have a new laboratory, which we are going to start now. So this is showing, I mean, the different so application like wind, photovoltaic, also electric autos and so on. And in the center, you have so-called smart transformer. That's just an example, something that can manage the electric grid. Anyway, we'll have actually more and more demand for the batteries. And then we have started this laboratory. We have got funded, and now we are buying equipment and building also competencies there for focusing on the batteries for the smart grid and also electromobility. And the nice thing is that we have very good knowledge of the battery technology, because here in Kiel, we have a very strong Institute of Material Science in the Faculty of Engineering. They are nearby us, and we are close cooperating, and they know very well about the chemical properties and the material properties. So we will focus on this. And then you see in July you see in this figure, apart from me, Sandra Hansen, which is a researcher of material science, is also co-responsible of the laboratory with me. And then our president of the region, Gunther, who wanted to give directly this certificate to us. So teaching, so you have, I think, all the information. Also, I think in the first presentation, which Professor Moira made, we have summer and winter. In the summer, it will some of you will already come in the summer. It's the sign of power electronic converters, mostly the power converter topology and modulation. In the winter, we have the modeling and control of power electronics. And then we have in the summer, there's also renewable energy system, where also battery is treated, and also electric drives in these that will be held by 2 professors, which they are from 2 University of Applied Science, which are cooperating with my team. One is specialist in electrical machine, and the other in control of electric drives. And then we have in the winter grid converters for renewables that are mostly power converters connected to the grid, or connected, for example, battery to the grid. So yeah, it's for you. So I mean, a look at what is power electronic in general, with the example of a computer which need say power supply, and then this power supply at different voltages, and then you have to connect to the electric grid, and then you have this power supply here. And basically power electronics present from 1 watt to 1 gigawatt. So you have also a high potential in saving energy when you use power electronics in application where it's not yet used. So power electronics spreading in a lot of applications. Don't think when you think in the automotive field, don't think only to the main engine, so the electrical machine which allow the auto to run, but think also a lot of other small a little bit smaller system, which they need the actuator in terms of electrical machine, then they have power electronics. And so the power electronic can increase the controllability and also increase the efficiency respect of using some mechanical system. So that is basically the main motivation. And some other application in which we are also present in wind. Of course, you have mechanical energy, and then you have a generator, and then power electronics to control the generator and connect to the electric grid. And photovoltaics, so of course, you have DC voltage, and then you need power electronics to connect to the electrical grid. But you can go also, for example, to high voltage DC when you have to transmit a high amount of power. That is basically also part of our scope of interest, because we are very active also in power electronics for the electric grid. We are in strategic programs in Germany, which are very long-term initiative about that. And of course, the e-mobility. So not only, as I say, the power electronic for the main machine, but also active suspension. We have done some work also in cooperation with some colleagues in Italy. Wireless power transfer, we also do that. So to charge the auto, maybe that is, they could be static or dynamical, so when the car is moving. Yeah, and then here you can have a look to the project so that you see a little bit more in deep what we are doing. These are all the projects that we have in the energy system, so field of electric vehicles. And just an example, the SkillFlex project is a project of the city of Kiel, where we consider, for example, the mobility of ships, of autobus, bus, and then of auto, and then the charging station, the impact of the electric grid, and so on. We have also a lot of projects specifically focused on electromobility, also with the local companies, where we have seen, for example, a nice presentation of the company in Hamburg, Neuville. They make this small trailer, but there's a very revolutionary idea, and where we are cooperating with them for the electronic of this small trailer. But also with other companies, local, in the regional, and also in Germany in general. Yeah, that is what I talk about projects. Then we go in some result. For example, I told about hardware in the loop and power hardware in the loop. So these approaches to test some hardware, some power converter, some control. That was the project I was referring previously. We have modeled active suspension. That is basically used for damping the oscillation, the vibration of the machine, and then you can use also to recover some energy. So with the colleagues of the Department of Mechanical Engineering in Italy, which we are still cooperating, is coming now, and other students from, then we make the full model of the entire chassis of the auto, and then we have part of these, as you see here, there's part on the bottom, you see, yeah, on the bottom here, you see in the, so the road profile, the suspension, also the rest of the vehicle is actually simulated in this supercomputer, and then there's a power amplifier which applies some signal to this inverter of Danfoss, and controlled by this space to control actually this active suspension. That was also, we are cooperating also with this space, because this space is in Paderborn, it's not far away from here. We have done a similar study also for testing, for example, smart transformer, again with part of the network simulated, and the power converter, which is doing the smart transformer in the laboratory. And the smart transformer, what is smart transformer? This is a slide which is partly coming with a project with the company Scottish Power with testing in Scotland smart transformer. Scottish Power is part of the multinational group Iberdrola, so quite a large group, and they want to see the potential of this smart transformer in the electric grid. So smart transformer can basically create some meshed network. So you see these loops here, you have this loop here, this loop, for example, DC, and they allow to control back the power flow, so they can avoid that some part of the network, they are overloaded. And typically when part of the network is overloaded, you have to invest a lot of money to reinforce the line. And then if you use instead the smart transformer, you can control where the power is flowing. You can save money, and you can also save the emissions, because basically using DC, you have a more efficient technology. This is a prototype which I built in the laboratory. Actually, this is the first version. We have built some new version, testing waveform and see the efficiency. And then we have focused also a lot on the reliability, introducing this concept of power routing. So basically, you see on the on this side here, when you have a modular system with a different cell, they manage the power. Then one of these cells is sometime get a failure or should be replaced, and then get some maintenance, and then come back into operation. And then at the end you have cells which have different lifetime, and then you try to stress the cell differently depending on their strength. So if they have more remaining lifetime, you stress them more, and those that they have a little bit weaker, you stress less. And so this is the concept shown here with the simple 3 converter cell, which they are connected, and in this case in parallel, and the power from balance became unbalanced because you see you want to, in some case, to increase the lifetime, because one component had a very low remaining lifetime. And then this is the other one, the 2 and 3, they are those that have more remaining lifetime, you can consume more of their lifetime. So these are some concepts that are coming in the industry, especially in the automotive sector, which they are developing control for the lifetime of the component. So basically, you are not only controlling current and voltages or speed of the machine, you are even controlling the lifetime of the components. Very, very advanced, and is from the industry, did come 30 years ago from the industry. So we make also studies with, you see this distribution, consider, for example, different cell. This is what you have in green, are different cell of, again, of a modular structure. And in green, you see if you don't do anything, they will fail between 19 and 25 years. And using our approaches, you get what you have in blue. So you have a more clear expectation when the cell they are going to fail. So you can basically also postpone the 5% failure probability, and you can make it narrow. So you have better expectation when to do maintenance. So this kind of concept, they are a little bit sometimes out of our electrical engineering background, but especially for a multidisciplinary master like you, I think it's something which can be interesting, because these are approaches that actually apply in industry. Another example, this large system which was built to test impedance in the electric grid. So here there are these 2 containers. We build the power converter and the control, and then we put into the grid some signal to measure the impedance of the grid. And you can do that, for example, also for batteries. In fact, we are also developing same concept for batteries, or sometimes to characterize the part of the powertrain of electric vehicle. We get some requests from some companies which they are active in this field. So it was a challenge, not only from the hardware point of view, you see it's quite a large system, but from control point of view, you see a lot of oscillation, and that you see here that you try to also have to dump. Yeah, another example is this high-speed drive. So high-speed drive, they are very often now used to also improve the efficiency, because you can avoid to have the gearbox, and they have a machine which is rotating at high frequency, which should be specially designed for that. For that reason, we are cooperating with this professor from the University of Flensburg, which is designing the high-speed machine for us. You can see here the high-speed machine was specially designed for that. You see here. And we have used some special power electronic developed in cooperation with the Danfoss Power Electronics here in the region, which are using also silicon carbide devices, is hybrid NPC system. Yeah, you see here, you see that this is the open module. Is something that we can only do because we have the cooperation of the manufacturer of power module, which actually produce some power module without the gel. And you see some of the devices, they are basically SiC MOSFET, some other classical MOSFET. Then we can see with this module without the gel, the temperature with the infrared camera. So we are going to look at this system very clearly, the temperature into the machine with sensor, into the power module, and then you can do several things. You can optimize the design, you can focus on the control and make the control also to take into account the lifetime of this system. So this is also a very nice application in the automotive field. And this you see also we make some estimation of the lifetime, considering different kind of modulation, for example, way of driving the devices. So we are really there where, so hardware, modeling, control, probability, they come together. So it's very multidisciplinary. And then for that reason, in the team, we have these 3 sub-team with people focusing more on the hardware, more on the control, and more on the application, and they cooperate among them. Yeah, this is the DC-DC converter, which was specifically developed for to be fault tolerant. Also, that is an application in automotive cases. And so this is shown here into the laboratory under test. And for example, we make one cell is failing, and then the system is continue to operating. So that basically the system should continue operate also in case of failure in a lot of application, electric grid, but also in the automotive, there is a lot of these requirements. Yeah, and that's it. And I would be happy to answer your question. I think I haven't used maybe a little bit less than half an hour, but I think it's very important to have some interaction among us. Okay.
Yes, thank you, Marco, so for this nice talk. Very, very interesting in the field of power electronics, and you have really many applications and many collaborations with academic institutions and with companies and industries. So it's very, very important.
Professor, I have some questions.
Yeah.
First, hi, thank you so much for the presentation. It's so interesting that you have many experience and many projects in the domain of power electronics, and I'm really proud that I have the chance to work with you next year on my 3rd semester in Kiel University. Actually, it's interesting for me to know more about the platforms, softwares, or applications you use mainly in your laboratories, because you mentioned 2D space and of course MATLAB, and I just want to know about other applications, other softwares or platforms that you mainly use in your laboratories. And another thing is that my question is that we mainly focus on automobiles, but it's interesting for me that what kind of technologies or progresses we had in domain of airplanes. It's really interesting for me that have you ever worked with a project related to airplanes or no? And it would be great if you can explain in this domain for us as well. This is 2 of my questions. Thank you.
Yeah, okay, so thank you for the question. It was my pleasure to have you here in Kiel. You also come in the nice season because the summer semester is a better semester. Yes, we work a lot with MATLAB Simulink. Now we have also a campus license, so as a student you will have the possibility from home to install MATLAB on devices and so on. And in the laboratory, of course, we use a lot this space to make a fast testing. For example, in so-called master practicum is the laboratory for master student, and actually there we use also microcontroller, and we go for the programming of microcontroller. However, the system that we have has the possibility to be controlled by DSpace or through a microcontroller DSP. So they use typically DSP of Texas Instrument, and so in our courses and especially in the laboratories, also the possibility to learn also a little bit about programming. We have also people who are very strong, for example, in programming of FPGA and so on. But coming back to the software, more for the simulation, we use a lot of different software. For example, we also use PSCAD for emulating the electric grid, and we use Maxwell or COMSOL for so the basically you can use for finite element simulation. So these are, I would say, these are the major ones. But I would say we are very strongly focused on using a MATLAB Simulink, because also, for example, the chair of control use a lot MATLAB Simulink. So I think if you come here and you follow different courses, I mean, you use most the same tools also for different courses. But of course, one make the thesis also we use, and we go also to other software. And there are some courses in which these other software, they are also briefly introduced. For example, renewable energy system, or yeah, this kind of courses, they have also a little bit of this PSCAD, which is to simulate the grid. Application on board in the airplane, we have been doing for research. At the moment, we have not specific research project about that, but I would say that so-called the topic of microgrid on board is important for the field of so transportation, for example, cars, but also for example, ships and for airplane. And there are similar problems in terms of integration of batteries and managing DC network, controlling the power flow. So once one learn something in this direction, can easily apply in a different kind of application. Yeah, thank you.
Thank you. Thank you so much.
Yeah, another questions?
Yes, hello, this is Oscar Leal. I also will be a second and third semester in Kiel University, and I was checking the syllabus. It says that we have a laboratory for electric drives, or a seminar. I was wondering if this seminar is, are we going to study the different control techniques for electric drives, for example, nonlinear control techniques or sensorless control techniques for example, PMSM machines? So that's my question so far. Thank you so much.
Oh, thank you. I'm a little bit unsure what you are referring to the course of electric drives.
Yes.
Yeah, the course of electric drives is basically we talk about electric drives. It's focused a lot on the control. Actually, is a basic control structure with some little bit in the direction also sensorless control and also, for example, field weakening and some more advanced topic, but is the classical vector control. And then there is at the beginning one part which is more about the machine. From the semester which you will come, I asked Professor Lolane from Flensburg to make this part of machine, because the professor of machine, because I wanted to reinforce the part of the machine, and also because in the automotive sector, so of course the design of the machine to make a compact machine is also quite important. So we will tell something more about the machine design and the operation, and then there will be a part more about the control.
Okay, thank you very much.
Please.
Okay.
Yeah, Professor?
Yes.
Okay. My name is Guilherme. Thank you for the presentation. I was really interested in how many applications and how many company you share the products you have research with. It's very interesting for engineering students to develop something and to see it being applied somewhere. So this is very nice. And I have a question, not a question, but I wanted to know about I am a little bit interested in medium voltage systems. What kind of topology did you use for that smart transformers that you showed us?
Yeah, first of all, yeah, okay, thank you for the question. I mean, the cooperation for industry for us is very important. We have cooperation with 20 companies, so most of all the topic which we are considered, they are in cooperation with the companies. There are some advanced topic in which we are so not yet a very deep cooperation, but at least we are in exchange with the companies, so we always get this feedback from them. In the field of the smart transformer, we are focusing a lot in the modular topology, like modular multi-level converter. So which
MMC.
one cell, MMC, exactly. And that is also one of our point of strength. We focus also on the managing of the medium voltage DC and also looking at management of failure. Actually, the interesting fact of this MMC is that you can not only use in the medium voltage, but also, for example, in automotive application to integrate the batteries in the vehicle has been proposed as a nice property, which can also be scaled to low power or relatively low power, but for automotive application, for example. Yeah.
Oh, thank you very much.
No other questions? Yeah, if you have another question, so don't hesitate to ask them.
Yes, I have a question. Hello. It's more general. I think that in the region, the proximity of Kiel, there are some harbors and many ships and submarines. And I am aware that these submarines, for example, use fuel cell technology. So I wanted to ask you if you have any kind of collaboration or research ongoing on fuel cells.
They are exactly in front of us, actually. The Faculty of Engineering, in front there is the Thyssen Maritime Group Systems. They are developing that. And basically my my ex senior postdoc, so the person that near me was managing all the team, Marcus Andresen, from the 1st of January of this year is a group leader there. So also some other ex-PhD are working there. At the moment, we had some, let's say, exchange, but we have not done yet something together. But the fuel cell, in general, the hydrogen is in the focus area of north of Germany. There is a North Germany Alliance, and so we will have a significant focus on this topic in the future years. So I say batteries and hydrogen will be significant in focus. It's true that I mean we have the harbor of Kiel, also of Hamburg, and that for that reason that there is this initiative I told you, which is called Captain Kiel, where we consider also the ships, because small ships, they go from one side to the other side of the fjord, because Kiel is, of course, as the fjord in the middle, and especially in the summer, you use the ship to go to from another side of the fjord. Sometimes it maybe faster with the bus, but it's, of course, it's nicer if you take the ship. I do a lot of time. And so there's also the idea to make this more sustainable, using instead of diesel, so electrical version. So this is for sure in focus of this university. Yeah.
Thank you.
Yeah. Good question. So maybe to have some complement to this discussion. So when you have to go from one side to another side, Marco, so maybe you need what is called a supercapacitor in order to have faster the energy quickly for small distances. do you are working about supercapacitors in this field?
I mean, the mixture of different methods, and I mean, like to use a supercapacitor and batteries together is perfect for this application that we have of this multi-port DC converter. So it's something that we have considered in theory, but up to now we have not been applying. But we are open to, of course, to cooperate also with you if you have some idea in that direction. And the fact is that in the region we have also one of the biggest European producer of electrolytic capacitor, which they are pushing a little bit more in the direction of electrolytic capacitor. So supercapacitor, they have their own point of view. They say that they are better, so we are cooperating with them. But I mean, it's fine also to do things with supercapacitor.
Yeah. Okay, so another question? So Marie-Pierre, I think we have still time for another questions. I don't remember what is the time of the next presentation.
Next one is in 10 minutes, so,
so
okay.
we have 10 minutes.
Yeah,
for,
maybe from my side, I would like to ask the students, because I've seen the presentation of the companies and what kind of impression have you had about this presentation? Was nice. The program organized with large companies and also the very spin-off companies like this one from L'Aquila, or for example this Neuville from Hamburg. They have done this incredible story with these trucks. They come also here to show one of these trucks you can connect to the bicycle. I almost convinced them to give me one to go to buy things in the city instead of using the car, because it's amazing. Actually, it's very light to move and they come with this simple idea, but you can change completely the way of delivering packages. But in general, what is your impression about this presentation of the companies? Also about the topics in which you see that maybe they stressed more?
Yeah, students.
May I talk?
Yeah.
Okay.
Marco, for your information, Sade is the representative of the students.
Okay.
Thank you. You know, Professor, I have been working as an engineer, industrial automation engineer for 4 or 5 years. And, you know, most of the time I felt gap between what we learn at university and what's happening in industry. And it always was like a gap for me. And sometimes it's really different what's happening in industry and what we learn in university. But the good thing that I realized about these presentations and this master program is that the topics are really connected. And in this case, it was really interesting for me, because before the, honestly, before the presentations, I thought that maybe it would be completely different and I will be, you know, familiar with something completely new. Of course, we learned many things in these meetings, but the good thing about EPICO is that these two are really connected, and I'm very happy because of this. And it was personally really interesting for me. And I was curious most about the software applications and platforms that the companies mostly use to test their products. And in this case, I learned a lot personally. It's what I think.
Okay. Thank you for the feedback. I think also I think the same, that this is one of the features of this master. Is quite interesting and is of course there are also more companies which they are available for you to make to write, for example, a thesis if you want in this region, but for sure also in the other partner they have several companies which there is a very close cooperation. And it's also nice that there is a very broad set of topics. They come from software to hardware and a lot of things they in between. And also there are some topics which when we come close to mechanical engineering, because of course the autos has also the mechanical part to be modeled. Also even leading with vibration and this kind of things. And some of these approaches, they can be applied also nicely in the electric vehicles, but they can also be applied, for example, in wind turbines. So we are damping the oscillation. So say we have this cooperation with my ex-university in Italy and with the colleagues of mechanical engineer. Now we have done this active substantiation. Now we are going to do something in the wind for the blades, for the vibration of the blades. So there are quite a lot of topics. They cover also a very nice wide spectrum.
Okay, and Professor, excuse me, I have a question or maybe suggestion, because I think that what I think and I learned from these meetings, FPGA is mostly common between the most companies and most applications. And it's something that I feel it can be a good option to put, I don't know, as a syllabus inside the courses, but it's really interesting to learn FPGA because we are from different backgrounds, mechanical engineers, electrical engineers, control engineers. So do you have any course related to FPGA or any opportunity to learn more about this or now?
Well, it's in the past we had the course about microcontrollers. Now the idea is to make the version with also FPGA, because also I have one very expert postdoc coming from Korea who is strong in this field, and so there is this a plan to offer this course. We cannot do in this semester, but in the next semester that will be possible. So for those of you that will remain in Kiel. Yeah.
Okay, thank you so much.
Thank you.
Professor, can I ask something else?
Yes.
Yeah, of course.
It was very interesting, the labs. It will be very good next semester if we can visit them, even though we know it's complicated because of the corona.
We are using the lab currently. So currently the students in our situation, in all the condition of the corona, they could come in the laboratory with some very specific attention, but up to now it was still possible. Yeah.
It will be very important for us. And I was interested about the microgrid lab. Do you already have made the real integration of the microgrid with the real grid, or also do you have some like small wind turbines or solar panels to do like real tests with this? With the microgrid?
Yeah, I mean the microgrid we have in the laboratory, and we are expanding now also to as I did show in other part of the laboratory, we are connecting to the real grid, or we are simulating the grid and so on. We have at the moment we are not connecting, because we have photovoltaic panels here, and also we are buying a wind turbine for the faculty. But at the moment we are not connecting to them to make a test. Is something that we can consider. We have considered when we discuss about the installation of PV panels in the faculty, to have also the possibility to connect to them. We also cooperate with companies in the photovoltaics. In Germany there are very strong companies like SMA, but also Huawei from China is very strong here in this field. Which we are also interacting, and so that could be also to go in this direction to make direct tests on this system. In my story, I mean, when I was in Bari or in Denmark, we did this kind of things also.
Yeah, in my old university in Florianópolis in Brazil, Professor Ivo Barbie has a lot of solar panels in his research center, and through microgrid, he also throws the energy to the grid from the solar panels. So it will be very.
I know very well Professor Barbie, not personally, but he sent to me also some PhD student that then made a PhD in my. But I know him from his research for his publication that I also used even when I was PhD student. I think now he's retired, but I think he has a kind of company. So yeah,
he still gives classes.
Okay, he's still doing classes. That's nice.
Yeah. Okay, I think. Oh, just one other question. By the way, do you also work with DC microgrids, or mainly for now is AC microgrids?
DC absolutely. DC is now one of the hottest topic in Absolute, having the DC microgrid. So also not only the management of DC microgrid, also protection for DC microgrid. When you have a fault, you cannot use AC protection, and we have some concept there. So we use with the low voltage DC, but also medium voltage DC microgrid. For example, you consider large charging station, power is extremely high, or data center, and then you have this medium voltage DC, something that we are doing in cooperation with companies. Yeah.
Oh, amazing! Thank you very much.
Thank you.
Yeah. So thank you for this interactions, Marco. So I think the students are very, very happy to hear from you what is really doing in your chair of power electronics. And on the next semester, they will be with you at university. So there is a COVID, of course, but hope that maybe some labs can be visited by students.
We will organize for sure. So I think I would say that the representative of the student when they come to put also directly in contact with me, and so we can organize that, because of course you are special students because you come from abroad, and then we can organize something on purpose so that you can benefit at the most from staying here.
Okay, thank you very much for
Male.
this information, for this arrangement issues. I think it's very, very important. Yeah. So thank you again, Marco.
Thank you.
And now we will switch to the next presentation from Renault Group about hybrid electrical vehicles. So this talk will be given by Ludovic Merien.
Yes. Hi, everyone. You hear me?
Okay, yeah, we hear you.
Okay, perfect.
Okay, thank you, Ludovic, for your coming to give this talk to our students, and you have maybe half hour or maybe more. It's for you.
So I want to share my screen.
Yeah, I think you have a right to share it. Marie-Pierre, you can. Okay, good.
Does it work in full screen now? Do you see it?
Yeah, it works good.
Okay, perfect. So I'll introduce myself. I'm Ludovic Merien. I have a Master of Engineering in Supélec in France, and now I work for 10 years now for Renault. So it's been quite long. I started to work on EV vehicle only because 10 years ago we were developing the Zoe cars, and some years after I started to work on hybrid when Renault starts hybrid project and hybrid vehicle. Okay, so I made a short introduction just to show you that EV and hybrid mainly are a big challenge for car manufacturer. As you can see on the screen, now we are in 2020. Hybrid and EV market share are growing really fastly, and we expect that this growth will continue the next years. So here it is in Europe, and here it is in France, a country in which we have quite a big upheaval, because in the last years, main technologies we sold was diesel, and thanks to, or because of, as you prefer, government, now it is mainly gasoline, and hybrid, plug-in hybrid and EV are growing. We expect that in the next year, maybe 5 or maximum 10 years, diesel will disappear and will be replaced by those technologies. Diesel will only remain for big vehicle trucks mainly, and not anything else. So today I will speak mainly about E-Tech technology, which is a new hybrid technologies sold by Renault. These new cars, we sell it for, I think we started last summer to sell cars, so it's quite new. I will tease some gearbox control issue it faces during this gearbox development, and I will introduce how we manage energy optimization inside the software, so how we reduce consumption in the software, and how do we control it. Okay. So to introduce the E-Tech technology, today we sell 3 different cars. Maybe you know Clio, which is a full HEV, so only hybrid, and Captur and Megane. Today we sell plug-in hybrid. So hybrid for smallest car and plug-in hybrid for biggest car. I will explain why it makes sense. So E-Tech, it is an electrified gearbox inside which we have, as you can see here, a gearbox which is the same technology as Formula One, which is a gearbox without any clutch and without any speed synchronizer. It is only dog clutch. It means that it's only neutral or on-off gear. So it means that if we want to engage, to use some gear, we have to first synchronize speed, so that there is not a too big gap of speed in and out of the gearbox. Okay, and in this gearbox we have a main e-motor, which is used to start the vehicle. As there isn't any clutch, we cannot start the vehicle with the IC, with the combustion engine. The only way to start the vehicle is with the e-motor, because it's the only motor that can produce torque at 0 speed, 0 RPM. Okay, and we have a smaller electric motor, which is which is a high voltage starter generator. But yes, if I want to compare the power, the main e-motor is 50 kilowatt power, and the smaller is 25. So it's smaller, but it's still big, as it can. We could drive the vehicle with a small e-motor to maybe 80 kilometers per hour easily. So smaller, but still it's a big e-motor. And the engine, the combustion engine, which is a simple atmospheric and straightforward engine, which has been mainly designed to reduce CO2 emissions, to reduce consumption. Yeah. And what is interesting with this technology is that for full hybrid or plug-in hybrid, it is exactly the same e-motor, gearbox, and combustion engine. The only difference is the battery. And for plug-in, the way that there is a charger. So for full hybrid vehicle, it is a small battery, 1.2 kilowatt hour energy. And I don't see, but there is your camera, but I remember 9.8, I think, kilowatt hour for the PHEV battery. And there is two levels of power because with the HEV battery, the voltage is quite lower. So even if it is the same e-motor, because of the lower voltage, we cannot reach the same power with the e-motor. You understand? Because the plug-in hybrid battery deliver in the mean 350 volts, whereas the HEV battery is nearer to the 250 volts. So because of this voltage gap, we lose some power, and that's why for HEV we have with the complete gearbox, engine, and e-motor 105 kilowatt power, and the same with the bigger battery can deliver 120 kilowatt. Okay, so size of the battery and voltage of the battery have a big impact of the power the same system can deliver. So the full hybrid model here, just to show how it is. So the battery is located in the back of the car and the motor is in the front. Here on Clio, we homologate at 96 grams of CO2 per kilometer. So to be honest, we had the objective to reach 90 because of government incitative, I think.
Yes. You're right.
And we will progress in the next year with the same technology. I think we will reach our first objective. So here, yes, it is how it is in the car. And the plug-in version, in the front of the car, it is the same gearbox, same motor. But in the back of the car, the battery is bigger and there is a charger with a trap, an access trap for the charger. So here, the plug-in hybrid will homologate with 32 grams CO2 per kilometer, which is a number that doesn't mean anything. In fact, it is just a formula we applied to tell this number, because a plug-in hybrid vehicle works in two main modes: EV if the battery is full, or when the battery still has energy, and full hybrid when the battery is almost empty. So it means that this capture plug-in hybrid, when the battery is almost empty, the system will work as the HEV version on Clio. The only difference is that the voltage of the battery remains higher, so you still have the 120 kilowatt power, but the emission of CO2 if the battery is empty will be near 102 grams CO2 per kilometer. And we can homologate with this 32 because the EV autonomy of this car is near 60 kilometers. So when we apply the formula on the homologation is to divide the hybrid consumption by the amount of 25 kilometers the car can do on EV mode. So here we have a bit more than 100. We can do almost a bit more than 2 times the 25 kilometers of EV autonomy, which is only in the homologation. So that's why we divide by 3 the consumption we have when the battery is empty, and that's why we can show this number. But to be honest, either you drive and you charge the battery every day and you will consume 0 grams CO2 per kilometer every day, or if you never charge the battery, you will consume a little bit more than 100 grams CO2 per kilometer. So when analyzing plug-in hybrid vehicle, it's difficult on the side of car manufacturer because we announce this number, but we don't know either the client will charge or not the vehicle, and we have an issue because quite a big part of our clients never charge a vehicle because we have tax incentives which help us to find clients, but when they benefit of this tax incentive, they don't want to charge the vehicle. We don't know why, because the vehicle remains cheaper if you charge it. We don't know why, but we see that now. And Toyota, I think Toyota have seen it a few years ago. That's why they reduce their plug-in hybrid offer now. But we hope that with this technology, which is cheaper than the Toyota one, we would find other clients. Okay. So here it's how it's inside the vehicle, the same. Okay, I check time.
Yes.
So regarding gearbox, here it is, in fact, mechanically speaking, the gearbox, as I said, which is used in Formula One, is the simplest gearbox we have now. It's only it's controlled by dog clutch, which means, as I said, that there is only neutral and on-off with any gears. And here in the gearbox, we have, in fact, 2 gearbox, one for the ICE line because the high voltage starter generator is always linked to the ICE, so it is one block. And for this block, we have 4 different gears. And for the main e-motor line, we have 2 gears, which means that we can choose independently the gear on the ICE line and the EM line, which allow us to give a feeling of DCT without any gap of torque when we change a gear, because as it is plotted here, when the vehicle is driven by the ICE and we want to change the gear, we will engage, if it was not already the case, a gear on the EM line, so that when we change a gear, when we have to open the gear on the ICE line, we replace the torque which was given by the ICE by the torque on the EM line. So that the sum of this torque, the power which was delivered at the wheel, remains almost constant, and the driver doesn't feel anything when we change the gear on the ice line. You can only hear it because the speed of the ice is modified. But this has to be finely controlled. So that's why we had some work. But now I can say that we do this torque balancing without any feeling inside the car. And I will go more deeply in this case, because as I said, there isn't any clutch in the gearbox. So if we want to start the vehicle, we can only use the main e-motor. This creates some difficulties because mainly when the battery is very cold, it cannot deliver a lot of power. So it means if the first gear of the ice I will say that the minimum speed of the ice in which we can use it is near 1,200 RPM. It means that we cannot use the IC gear unless the speed of the vehicle allows us to engage a gear in which the speed of the ice will be higher than this 1,200 RPM. It means that with how we design the gear, we cannot use ICE gear unless we are above maybe 18 km per hour. So we have to use the EM only to reach this 18 km per hour. But as I said, if the battery doesn't give us enough power, the only way is to generate power by the high voltage starter generator. So we have this constraint that we must, in some case, use the car as a pure serial hybrid vehicle. Serial hybrid, it means that the combustion engine gives the power, the high voltage starter generator converts it in electricity, and then the main motor can use it to create torque and create power and transfer power to the wheel. So how we design the control for this? In fact, we have the IC line, which is standalone, and we have two things to control: the speed of the starter of the high voltage starter generator, which I'll call HSG, and the IC, the speed of this block, and the electrical power that it will create. So we choose to control the power that will be created by this block using the torque request on the engine of the IC. And we choose to make the speed loop using the HSG. Why we do that? Because the charging loop, we don't, as we have a battery, we still have a battery. It is not the loop which need the more dynamic response, which needs a more dynamic in the response. And our actuator, which is the slower actuator, is the IC. A combustion engine is really slower than an electrical machine. If I want to give you an example, for a combustion engine, if it is already running, but if you want to change the torque request, it will take at least 200 milliseconds to change and to realize the new torque request we send to it. Whereas the HHG, if we change a torque request, it will only take 10 milliseconds to adjust the torque which is realized. Okay, so the electrical part is really fast when compared to the combustion part. That's why here the charging loop, as the speed will be controlled, and when it is stabilized, all the energy that is produced by the IC will be converted, will be absorbed by the HHG. So if we ask the IC to produce 10 kilowatt power, it means that if we consider 100% efficiency, that the HHG, when the speed is stabilized, will generate 10 kilowatt power, and will, if there isn't any consumption, will charge the battery with 10 kilowatts. So here, one loop regarding charge, it is it's not really a loop, as we only have a charging power target. We convert it in high torque request, just using high speed, and that's what we send. And the speed loop, which is I can say it's a PI loop to simplify. Speed request, speed measured, and we calculate the torque request. The issue we faced in a bit in the end of the project is that sometimes when we want to reach the limit, I mean, we cannot charge a battery with too much power, especially when the battery is really cold. We have really big constraints, and in this case, if we cannot charge a battery more than some kilowatts, for example 1 or 2 kilowatts maximum, it means that if we want to control the power here we generate, we have this 1 or 2 kilowatt power precision which is needed on the IC line, and especially at low torque, the IC can produce torque, can produce power, but plus or minus 5 kilowatt. So what we face is that the speed loop wasn't stable because of this torque request saturation due to battery limitation. So what we add is that we inform the charging loop of this power saturation inside the speed loop, and we decrease the charging loop power if the HHG torque request is near saturation. So the two loops are still independent, because here the loop still controls the speed, and here the upper loop will control the torque margin we have on the HHG limit. And it worked well, and that's how we manage it. And if I want to introduce the last topic we worked on, is that it is the case where if we lose the battery. So here it is the thesis on which work Sébastien Rouquet in Centrale Nantes, and he worked on this problem. How can we manage such a serial hybrid control in the case that we don't have the battery, in the case we only have a small capacitance, a small capacitor to only filter the energy, but so it creates more constraints, but it is a really interesting topic. And I won't tell you this because I don't have time, but you can contact, I think, Sébastien Roquet in Central Nantes if you want more detail, but it is a really interesting topic. Okay. And at last, I wanted to speak also about energy optimization and our consumption minimization strategy. So when we are in a hybrid vehicle, our goal is to minimize CO2 emission. And as we have an electrical source of power and an IC source of power, what we can do is choose how we balance the torque between this IC power and the e-motor. And the constraint is that the driver, when he pushes the axle pedal, we convert this information in a wheel power the driver wants. So this P0 is a constraint, and if we realize this P0, we can choose how we realize it when with a part with the IC and another part on the EM. How we do it? At each time, we will calculate what we call an equivalent consumption, and we will calculate it with this formula. We use what we call the equivalent factor. This factor converts electrical power in consumption of and in CO2 emission, in fact, so that when we test the different way to realize the driver wheel power, we can compare which combination of torque on IC and EM will do the less emission. And this equivalent factor, we use it as a way to control the state of charge of the battery. And how it is done? So when the battery is fully loaded, this factor will be very low. It means that if we have to, if the driver wants 50 kilowatt, as this factor is very low, two cases, 50 kilowatt done by IC or 50 kilowatt done by EM. 50 kilowatt done by IC would have some consumption. If this gain is very low, 50 kilowatt of battery, it will be almost free. So when this equivalence factor is low, it means that we will drive almost only an EV vehicle. And then when the state of charge of the battery goes too low, this equivalence factor increase, which means that we will use more and more IC power, and maybe if this factor is very big, it will lead to use even more IC power than the driver will, just to be able to charge the battery. I can show you here how it is done. So here I plotted IC consumption depending on the power. As I said, we will take the example that the driver wheel is 50 kilowatt. So here, the sum of IC power and electrical power always does 50 kilowatt. As I said, if we add this electrical power but multiplied by the equivalence factor, in the case it is low, plus the IC consumption, when we minimize, when we look for the minimum of this graph, it leads to use only EM or almost only electrical power. When the equivalence factor increases, here, when we look for the minimum, it leads to use more the ICE and a bit less the electrical power. And as I said, there is a value in which we use only the combustion engine, and if the value is high enough, it will lead to even if the driver wants 50 kilowatt, we will create more power on the AC line to be able to charge the battery. So this is the way we manage the energy inside the car, and this is the way we can guarantee that the battery will never be fully empty. As it was shown here, on the left part of the graph here, it is the hybrid area, and on the right part, it will be the EV area. So this is how we control the state of charge of the battery inside the vehicle. Okay. And so this energy optimization, yes, as you can see, it is only a way to optimize at one moment one driver wheel, how we will respect this driver wheel and discharge or charge a battery. Here I plotted it only for one gear, but this calculation can be done for all the available gears at the same time, and we can find the minimum for one gear, check the minimum in one other gear, and how we choose to change the gear could be also to choose the gear which has the minimum cost of energy. And with some other constraints, this is mainly how we choose the gear with our technology. But still, this is only to optimize one moment. If we want to optimize on a complete journey, the only way is to know the journey. So we could use our GPS data to know the road the driver will take and modify our equivalence factor data to better use the electrical energy all along the journey. It means here, it is an example. What I show you on the equivalence factor is that there is an EV area and a hybrid area. This means that when we are in the EV area, we will only use electrical energy, and at last the car will operate as an hybrid vehicle. So this means it is a depleting use. We will discharge the battery and then sustain the energy. So this is what I show you here in red. If we do this with this type of road, urban, highway, and then urban, with a hill here, then we go to the valley and here. So when when we mount here, we will use a lot of energy. Then here, we will use less. Well, you always have to some consumption on electrical because you have the lights and other. So that's why here the SOC doesn't increase. But here it is depleting and then sustaining. If using the GPS data, we would know that we would have urban driving at the end of the journey, it is more efficient to keep some electrical energy because on highway, the energy mainly comes from IC, mainly comes from a combustion engine. So there isn't any difference knowing or not knowing when we are on highway. But when we are in the city, it is where we want to have the more EV feeling, the more EV in the vehicle. So here, without knowing that we will have urban driving at the end, here, when we arrive in the city, we are already in hybrid mode, so we cannot guarantee full EV driving. But using the GPS data, we can tell with the software, we can keep some energy in the battery here to allow the driver to drive in full EV and at the end of the journey when he reaches the city. Okay, so if I summarize these points, the idea is to minimize, the idea of the first part is how we minimize consumption, but without knowing the journey. Just at this moment, what wants the driver, what is the state of charge of the battery, how we do it. And what I show you is not only used by Renault, but it is widely used among car manufacturers. I know Renault, we worked with Nissan, so they do the same, obviously. And I know that some German car manufacturer uses this ECMS strategy also to control the SOC of their battery, Mercedes especially. Okay, so yeah. Yes, I think the time is over.
Yeah. So thank you very much, Ludovic, for this nice talk about what is done in Renault. Yeah, about optimization aspects in hybrid electrical vehicles. So it's very, very interesting to.
Yeah, there is really a lot of topic. So yeah. Here the time was quite short.
Easy. Yeah, I agree with you.
I choose to make introduction of several topics, but
it's not easier to present all together. So you have chosen some topics, of course. So I think it was very, very interesting. So maybe there is some questions from students. So if you can ask us questions to Ludovic.
Yes, Professor, I have one. Yeah, first I'd like to thank you a lot. It was very interesting, especially about optimization. Sounds like it is not so obvious that navigation data can help even in EV application, not only in hybrid, in EV, also it helps to at least to give a view to the driver, how many kilometers it is left for him. Yeah. Because sometimes we know that there is a problem. If we have navigation and we're telling him we're going to Paris, it will know definitely when we will stop, and it will something like say that we need to stop. So I'm just trying to say that it's a great idea. It's a very interesting topic. But my question was simpler because you answered quite a lot during the talk about battery. I was surprised that in the photo of the hybrid batteries for the series parallel hybrid vehicle, it looked like a usual acid battery. No, I'm just surprised that you have very different batteries for the plug-in hybrid and series parallel. Not by size, but it seemed like, you know, the usual in the car. In internal combustion engine car, we have the accumulator, this really heavy, dirty accumulator. Do we have the same in series parallel or from lithium?
In fact, on the inverter side, we always have a small accumulator, but which is used to filter the voltage variation on the inverter side. So there, we can only store really few energy in this accumulator. So so that we use the battery.
But could you show in the presentation? Sorry, yes, in the presentation, the slide when you only had batteries. I'm just surprised how the model is simplified for the battery. I know that they are smaller than for the plug-in hybrid, but it is just surprising that it is so simple, that no cooling system, even it seems bigger and heavier.
Yes, I show a simplified representation. There is a cooling system. There is everything.
Oh.
But I choose to simplify and to show this because I want to go deep in in this control theme.
Ah, yes, okay, yes. I was just interested how different do you try to save money on batteries for hybrid parallel vehicles? Because of course, if we take electric vehicle, we should have the most expensive, the better one, to have the power density, the great power density. But what are the requirements for series parallel?
In fact, except the battery size, we have the same. All the rest is the same. It's the same cooling system, PHEV or HEV. And as it is the same. It is the same motor. Everything is the same. Only the size of the battery. And I think we for HEV, to be honest, it's a bit more expensive because EV and PHEV is could be simpler as when you drive an EV, you use the electrical power to respect the driver wheel. So you just only see the driver wheel. You know how you will use the battery. And in HEV, you will have several cycles in which you will discharge, and then you will have to charge the battery because you have a few capacity, a few autonomy. So you will have to make many cycles to discharge charge, and this leads to more constraint, and that's why I think in HEV car we use we have a better how can I say it? We will in the end we choose to have a water. I don't know how to say it. Sorry.
No, don't worry. Yeah, it's right. We're in France.
So on PHEV we have a blower to manage thermal problem, and on HEV we have a water circuit to manage. Because of this cycle, we will do more and more discharge and charge.
Yeah, it is very interesting. Thanks a lot. Because I was just always disappointed the difference between the price of plug-in hybrid and hybrid, and always tried to understand why Toyota just added 2,000 euro while the plug-in 12,000 to the model.
The main difference is the battery cost, because each cell of the battery costs a lot, I'd say, and that's why.
Yeah, maybe. Maybe just a comment about this, Ludovic. The power is not the same in
big plug-in bigger. I know. No, more powerful there.
Yeah.
In plug-in.
In plug-in is more powerful.
Yes.
Because you can charge it and so on. So this issue also it's very important.
Yes, but on battery side, as I said, the difference of power is mainly linked to the voltage, but instantaneously, HEV and PHEV battery almost can deliver the same power. Okay. I mean here on E-Tech, the plug-in hybrid battery can deliver 70 kilowatt power maximum instantaneously, and the HEV it is 55. So there is difference, but it's not so big.
Yeah. Exactly.
Yeah. Thanks a lot. Thanks a lot for the explanation.
Another questions? Yeah. So we have still some time to ask another questions. Okay. Do you hear me? All students hear me?
Yes. We're hearing. I'm just recapping the presentation to remember what was also very interesting to ask. Yeah, I'm just recapping the presentation.
Yeah.
I'm just trying to explain that even hybrid vehicles are just sometimes even more interesting because we have more requirements, and so
it gather conventional and electric vehicle difficulties, in fact.
Yes, and that is why something like when we see the prices for fully electric battery vehicles and think how they can be cheaper than hybrid, or how to make hybrid more attractive. I mean, to the consumer, that it will be still buying in there all over the world. For example, in Russia, because of the prices for oil, it is not so lucrative. Yeah. You won't save this money maybe for 6-7 years, so it's too long. So I mean, the lower the price, the better. So
yeah, but now what we reach with our E-Tech technology is that our hybrid vehicle, the price of our hybrid vehicle is almost the same at what would be the diesel version of our vehicle. So that's why I'd say that the hybrid technology will replace the diesel in the next years.
Yeah, it's very interesting. Yeah, really a great improvement.
Actually, I have one question, if there is time. What I want to ask is actually regarding the statistics which you showed us, that in the market in the next 2-3 years, the percentage of plug-in and the normal full hybrid electric vehicle are going to take a major share.
Yeah.
So the question, what I'm thinking is, is it the market growth is there in that sector of hybrid vehicles? Because there is a lot of challenges in the pure battery electric vehicle, or how is that projection as in an industry is seeing? Why they are not focusing more towards enhancing the batteries technology so that it can be pure electric vehicles? Or I hope I made the question clear.
Yes, I think what I can say is that as we said, now the battery are still expensive, especially if you want to reach the same autonomy as a conventional vehicle.
Yeah.
So if we don't want to lose or to fail our clients, we cannot propose a small electric vehicle with, it could be great to have 1,000 kilometer autonomy, but the price would be maybe 15,000 euros more. We won't sell this vehicle. So we know that this hybrid technology will allow us to do the transition between conventional to full electric. Maybe in the next 20 or 30 years, we will do some cheaper battery with really big autonomy. There are a lot of work in this field with new battery technology without lithium mainly, or with solid battery. But we need technologies now, so that way we choose this hybrid, and at least we will keep it for the next 15 years at least. But I think it will be more, because now we increase the size of the battery. We found places in the car to put it, but it will take time to produce full EV vehicle at the price Renault wants, with more than 1,000 kilometer autonomy.
I understand what you just said, because using the word transition. So when the battery technology is fully evolved, where it is more affordable and there are alternate methods of getting the battery materials. So this transition is going to be gapped by the hybrid and plug-in hybrid vehicles, like you said, in the near 10 years or 15 years.
And what we expect is that maybe in 20 years there won't be any conventional vehicle. There will only be hybrid and EV.
Okay.
Yes. Yeah. Thank you, Vinod, for your comment. So just maybe one remark, Ludovic, about this hybrid electrical vehicles. What is the ongoing issues considering or according to fuel cell vehicles, hybrid with fuel cell, not battery? So there is a future with this, or it still needs some improvements? We
have project internally. We worked on this technology. On my side, yes, there is a bit of control to do in fuel cells, so I could work. But what I show you, in fact, we can take the battery and replace it by a fuel cell. The system could work as it is now. So to me, the fuel cell is only one kind of a battery. And I think that unless the battery technology make a big gap and we can produce enough battery for global production, we will need fuel cell technology just to allow the maximum of client of person to have access to this electrical technology. Because I don't know, but when I was student, one of my teachers said that there isn't enough platinum to create enough fuel cells to replace all the car in the world, and there isn't enough lithium to do the same. So if we want to replace all the car, we cannot do with only one technology. We cannot do it with only one technology.
So, but about the cost, maybe fuel cell is.
Now fuel cell is really more expensive.
As you said, maybe due to the platinum material. which represent, I think, if I remember, 80% of the price.
Today, using fuel cell vehicle? No, it's not 80%.
Or the fuel cell. I mean the fuel cell itself. The platinum material represents maybe nearly 80% of the fuel cell price.
Oh, honestly, I don't know how much the platinum represent. I don't know.
Maybe the limitation of the fuel cell due to the material.
Now I know that the fuel cell is much more expensive, and I know that we are facing a much more safety issue. It means that with our battery now, what we fear the most is that the battery burns. In fact, if you have your battery, if you charge it too much, it will burn.
Yeah.
It will burn, but it doesn't explode.
Yeah.
A fuel cell, we have another level of safety.
Of course, yeah.
So
some hydrogen issues.
Yeah.
You have to manage. There is maybe no more hydrogen stations than electricity.
Yes. We have also this issue. Yeah. There is electricity everywhere. There is not hydrogen everywhere. Yeah.
The network of charging stations.
Yes.
Hydrogen could be managed, and so investment on this area could be.
Yes, we'll need a lot of investment to propose this technology, I think. Yes.
Yeah, maybe.
But in Germany, I think they are working in this field for years, and the country, I think, I'm not sure, but I saw that maybe 20% of the fuel distribution also propose hydrogen in Germany. So it is only if the government want to invest on this technology.
Exactly. I have seen. I think it is the second country, if I'm not wrong, that has more hydrogen energy station charging stations. I think the first country is Japan, and after that maybe Germany. I agree with you. You're right.
Okay.
So if you don't have further questions.
Just a small question maybe about daily activity. Yeah, I just wanted to ask about daily activity. What is your responsibility within? Because we saw energy efficiency, just hybrid in general, but what is the daily activity for you as an engineer? Because it's also very interesting.
Oh, my work personally is to make software. So I work mainly on MATLAB Simulink or MATLAB, if you know, and I make almost all my codes on this with this software. For our test car, we use, I don't know if you know, D-Space, it's a German company. Using MATLAB, we can generate auto coding and auto compilator to generate a real-time software with a Microtobox or Autobox from DSpace. We put it inside the car, and so my work is mainly this to code and compile and test strategy in the vehicle or on bench when I start on e-motor.
Yeah, that is great. Yeah, just I mean, interesting because we're talking a lot last days about in general, but it is also very interesting just what is the application, because you know it's like working in Airbus. People thinking like, oh, it's so interesting to make airplanes, but you know every person is responsible for one part. I mean, and that was interesting. What is your part? of the whole hybrid technology. And I see now, yeah, that's thanks a lot for the whole presentation and idea about navigation.
Yeah, thank you, Ivan, for these comments and these questions for Ludovic. So if you don't have any other questions, so I propose to you to stop here. Marie-Pierre, we can stop now here.
Yes, you can do the final talk and everything is fine.
Yeah, so thank you a lot, Ludovic, for closing, let's say, this winter school by your talk about hybrid electrical vehicles, which was very, very interesting for our students. And I would like also to thank all the speakers of this winter school for supporting speakers from, of course, companies, partner industrial companies. So for supporting the master first and for accepting to give a talk in this area of electrical vehicles, management, control, and sustainability, and so on. So I think it was very, very interesting for our students. They like this all presentations. So I would like also to thank you, students, for your comment, for your interactions with all our industrial partners and academic also partners. So it was a pleasure to share with you this event. So, and I hope that it just the first event of this master. So we will have for sure another other events on the next year, and of course we will have so it was winter, and for sure we will have another school in summer, and I hope that it will be face to face. It's very important, and the COVID situation will be behind us, and the pandemic crisis will be improved, and so on. So this is our, I think, all our hope. So maybe Marie-Pierre, you can say some words to close definitively this school.
Yeah, so I will just tell the same as you just said. Thanks everyone for joining, you EPICO students and also the industrial partner. And I will be sad when all the EPICO students will leave for the next semester.
Yeah, so keep in touch. You are leaving to, yeah, the other countries, but keep touch with Centrale Nantes. It's very important. So it's just a joke. Okay. So thank you very much again. So see you next time, and keep you safe. Very important.